All right. Any volunteers to start us off with a prayer? Anyone? Anyone? Okay, go ahead. Thank you. Sure, go ahead and stand. Amen. Thank you. Remind me your name? Mara. Thank you, Mara. Okay. So we'll have lots of days that will be like this. I start off with a slide like this that has some problems, and we will go through these problems, and as I go through, we'll try to answer your questions that you have from this section, and hopefully solidify what needs to happen, or what you're supposed to learn. I don't know how long the slide's going to be up, so it's a good idea to take a picture of the slide so you can be working on and so you can be working on them as we go through. So, we'll start off with, take some time to do this. I'll open up for questions though. Questions on 2.1 and the stuff you read from 2.2 so far. What questions do you have on that material? Yes. Oh, so the question was, if we had an x squared, would you be able to do the matrices with just the coefficient? So if you had a system like if you had 1x squared plus 3x plus 5 equals 0 or something, plus y equals 5 or something like that, and you had another one, x plus y equals 7. So if we had a system like this, could you use matrices? No, we're limited here. Sometimes there are some tricks where you can do a substitution. There's some problems at the end of 2.1 that aren't linear. Like it has like a 1 over x plus 3 over y equals a constant, and then 2 over x plus 2 over y equals a constant. And these aren't linear, but you can substitute like s for 1 over x and and t for 1 over y. And then you can put it into something linear to solve for s and t, and then you can end up solving for x and y. So sometimes there's some substitutions, but yeah, linear algebra really focuses on the things that are linear. And so everything needs to be degree 1. So this is not linear. So great question. Great question. Other questions? Yes, Mara. That's supposed to be the augment bar. Yeah, so I didn't know a good way to do this in the word thing. So yeah, that's just supposed to be the augment bar. So this is an augmented matrix. You can think of it as a system of equations, and that bar is just showing which ones are on the right-hand side of the equation, which ones are on the left-hand side of the equation. So, okay. All right, other questions? Systems of equations are something that you guys have all bumped into before. So not a lot of new content in 2.1 and 2.2a. How many of you have done like row reduction before in matrices? Oh, so that's a new one. Okay. I don't do that as much. That's okay. That's okay. I assumed like half of you would have seen it. So thanks. So that's going to be the big thing we're going to be working on in the next couple days is how to row reduce matrices. Okay, so you got some flavor of that. Here I have a couple examples for you to row reduce. First one's not that bad. But why don't you take 5 or 6 minutes and do what you can on these, and then we'll start going through them as a class, okay? And if you've got questions, you can raise your hand. I'll come on over. And this is a good opportunity to just do the best you can, make mistakes, try to do it the way you think you would do it, and then when we go through a class, you can see where, like, where you did well and where you didn't go well, and you can learn that way. So. There's a start on the board if you guys are stuck. There are multiple ways to go about doing this. You don't have to go in an exact order, but there is a nice method that tends to work every time. Sometimes it's not the fastest, but it does work every time. Yeah, you're certainly welcome to work with your neighbor. All right, so one of the questions that came up as I was walking around was, is there a certain order to go in? I mentioned this, but it was quite quick on the video, assuming more of you had seen this than had. In general, this is the pattern you want to do. It's not always the best pattern. Sometimes it can save you from work by skipping some of these steps, but generally you want to make this one 1. It's upper left-hand corner, you make it a 1. There are 2 ways you'd make 1s. You can multiply a row by a non-zero constant to make this a 1, or you can swap rows. You already got a 1 down here, swap the row, and that's really easy. And then you use that 1 to make this 0. How do you make zeros? You add multiples of one row to another row. So then you use this, you get this to be 1, you use that 1 to make this 0, you use that 1 to get this 0. And then if possible, you make this one 1. Again, you might swap to get a 1, or if this was a 5, you multiply by 1/5, and you get a 1. Then you use this 1 to make this 0. And then you turn this into 1 if you can. If these are all 0, then that's all you can do. This might end up being 0 as you work through. But if you can make this a 1, then you make the ones above it zeros by adding multiples of this row and adding it to that row, multiples of this row, adding it to that row. And then finally, you can use this one to add it to this one here in the center to get that 0. And this pattern is nice because it keeps you from undoing work you've already done. So using this 1 to make these 0, or to make these 0, if these weren't already zeros, then you're just going to be changing these ones above it. But you already worked hard to get to these certain things. So that's the order that we kind of go in. I said it's not always the best. Sometimes, if this is 3, if this was 3 and these were multiples of 3, I'm not going to make this a 1 and then multiply by 6. I may as well just multiply this by 2 and multiply by -2 and then multiply by 2 to get rid of those before I make it a 1. And it also might save me from dealing with fractions. So, okay, any questions on this? Just kind of general pattern. Okay, where do rows of zeros go? Where do you want to put rows of zeros? At the bottom. Where do columns of zeros go? All the way to the left. So if we have a column of zeros, you want to put it all the way to the left. So it might be a case that we can't do anything with this one. We move over here. That's what we'll try. Unless there's another column of zeros, then you move over to the next one. Okay. So I use this 1 This was already 1. Nice. I used it to get the ones below it 0. And then I want this one to be a 1. What's the easiest way to get this to be a 1? Just swap these. So okay. If I was going for row echelon form, not reduced row echelon form, but just row echelon form, this is far enough. Okay. These diagonals, they just happen to be 1s. I haven't done anything to try to make them 1s. You know, I haven't had to divide or multiply by anything, but they just happen to be 1s. They don't have to be 1s for row echelon form. But it's in row echelon form because we have our zeros in staircase fashion here. Okay, I mentioned on the video, echelon comes from same word in Spanish for escalera, or what we use in English, escalator, comes from this levels idea, the stairs idea. Yes? That's okay. We could have zeros up here too. Yeah, it's okay. It's okay for these to be 0 also, but we want to make sure that, and the stairs, that they're always 0. And it doesn't have to just go over by 1. You could have, your stairs might be, they might be something like that, just depending on how many rows of zeros you have and how many where your pivot positions are. Okay, so we're going to keep going and get into reduced row echelon form. That's where we're going to go most of the time. Row echelon form, though, is nice. One of the things we use row echelon form is we can figure out what columns are pivot columns, or where our pivot positions are. We don't have to go all the way to reduced row echelon form. And sometimes we'll use this just to figure out where our pivot columns are. So here we have a pivot position, pivot position, pivot position. We have 3 pivot positions. All 3 of these columns are pivot columns. Yes. It's not Caroline. Madeline. Okay. They help us find, the main thing right now is they're going to help us find solutions to this system of equations. They're going to help us later when there are other ways to view this matrix, and they're going to help us later with those other things. But right now, they're going to help us find the solution for this system of equations. That's right. Yeah, so we're going to end up going, and so we have just a 1 here, just a 1 in this column, a 1 here in this column, and a 1 here in this column, so we can just root off x equals this, y equals this, z equals this. There are other things it tells us, but we have to get further into the class before we talk about it. Great question. Okay. So now I'm going to use, look at where I'm at on this. I've already used this one to get zeros here. We swapped to get a 1 here. We already had a 0 here, so I didn't have to do anything. I've already got a 1 here, luckily. Now I'm going to use this 1 to get these 2 above it to be 0. And then I'll use this one to get the one above it to be 0. Because reduced row echelon form, any pivot position I have needs to be a 1. And all of the other entries in that row of a pivot in the column of a pivot position needs to be zeros. Okay? So since these 3 all have pivot positions, everything else, I should just have 1s on the diagonal and everything else should be 0. So I'm going to keep this bottom row, then I'm going to multiply by a -2 and add it to this row. So a -2 times row 3 plus row 2, and that'll get me 0, 1, 0. So a -2 here is going to be a -0.5, and then add here, and I get 0.65, is that right? And then this is already 0, so I don't have to use this one to make that 0. I'm going to use this one, though, this one, to get rid of that one there. So I'm going to multiply this by just a -1, -1 times row 2, and add it to row 1. So 0 times a -1 plus 1, just 1. 1 times a -1 is a -1, plus 1 is 0, zeros. Here I get a -0.65 plus 1.5. What do I end up with? 0.85. So if we did that right. And now I have solutions. Like now I can just read off the solutions because I've changed this from the system that would be x plus y equals 1.5, x plus y plus z equals 1.75, and x plus 2y plus 2z equals 2.65. And I've changed that to x equals 0.85, y equals 0.65, and z equals 0.25. Okay? Questions? Yes, Christine and then Philip.
I think we're just doing this, like, I understand, like, what we're doing with the math with it, but I don't understand why you choose the things you do to, like, I guess I just don't get the strategy of what to pick first and how to get certain zeros.
Okay, we'll do a few more of these and try to get the strategy. That's all we're going to pretty much be doing this week. So, okay. But in general, so for those online, the question was, like, what's the strategy? It's hard to pick up the strategy on what do you use to get the zeros and the ones. In general, you get ones by swapping and multiplying. So by swapping rows and multiplying a row by a constant. And to get zeros, you add a multiple of one row to another. Okay? So if you want a 0, you want to be thinking, hey, I'm trying to take one row, multiply by something, and add, so I can get that to be a 0. If you're trying to get a 1, you want to swap or multiply by a non-zero constant to get it a 1. We didn't have to do a lot to get 1s because there were already tons of 1s in here. Okay. Do you want to pull up the things? Okay. One of the questions we're going to jump down to 3 here. Use the solution of 1 above to find the value of x plus 100y plus 100z. Okay. X plus 100y plus 100z. Just take a minute, do that problem. It's a little arithmetic here. Shouldn't be that hard. Someone have an answer for us? Yes. What was it? 9.85? I think we should be more than that. 90.85. There you go. 90.85. Nice. Okay, guess what we just figured out? We figured out the price of an In-N-Out burger if you order a 100 by 100. So, but these are 2004 prices, so it's more expensive now. But so what did we just do here? So there, someone actually ordered a 100 by 100 at an In-N-Out. There you have it. Kind of makes you sick. But where did we get the system of equations from? The system of equations is right over here. see if you can figure out what x, y, and z represent in the system of equations and how we got it from here. You're welcome to talk to your neighbor. I shouldn't use this example during dinner time. Okay, someone figured this out? Yeah, go ahead. Let me bring the mic. Remind me your name. Rip.
Yeah. X is the bun, Y is the meat, and Z is the cheese.
Okay. Very good. Did you guys get that too? Maybe technically the bun and like any other toppings, but yeah, very nice. Very nice. There is a slightly simpler way to do this problem. You don't have to do a 3x3. You can end up doing a 2x2. If you only care about a 100 by 100. But if you wanted a 100 by 50, then you actually do need three equations. Yes, Michelle. Oh, so again, the X is the bun and toppings, Y is the patty, the price of the patty, and Z is the price of a slice of cheese. And we can check and see this is the actual receipt. You can see it's 2004. Oh, look, it's Halloween. If you knocked on the right door on Halloween in 2004, look what you would have got. And what did we end up with? 90.85 pre-tax right there. So good job. Okay. Let's go to let's do something boring now. Okay, why don't you guys start working on 2? All right. Let me explain. This also has a context, this problem. This is return in percentage points, and this is beta. For those of you in the financial, going into finance, beta is a measure of risk when it comes to stocks or ETFs. This is the QQQ fund. It's an ETF that follows, an exchange traded fund that follows the NASDAQ. This is, I think it's XPXL. It's a triple leveraged fund that follows the S&P 500. And this is URE. It's a double leveraged fund that follows the real estate market. So what are we doing? We're basically creating a portfolio. So I have a goal. I would like to make 21 percentage points a year. This is my goal. But I'm willing to accept this much risk. If I wanted more risk, I could shoot for something higher. Those are kind of high. 21's it's an amazing year for those of you that know. I just picked some that had higher, high yields because they also have higher betas. So we're working with some numbers that aren't super small. So, and this is the kind of thing that people do with portfolio management. This is an overly simplified example, but I can post some slides that show a couple different ways that they do it, and they're using linear algebra and multivariable calculus. So the question is, like, how much of each of these do I need? How much do I buy of QQQ? How much do I buy of SPXL? And how much do I buy of URE to get my goal? So how many solutions am I going to have in this case? Why infinite? Or underdetermined? Yeah, underdetermined. So how do you know it's underdetermined? Yeah, there's more variables than there are equations. So we know for sure that there has to be, there's going to be infinitely many solutions here. So, so we only have 2 pieces of information at most, and we have 3 variables, so we can't solve one for each variable. There is one more constraint that we could add on. If you want, you can do this system. I don't know if we'll get to it, but you can add that the amount of money that goes in this fund and the amount of money that goes in this fund and the amount of money that goes in this fund has to equal 1. So you're going to find out, you're going to force these to be the proportion of money, the proportion of your fund that you're going to go into each fund. So this is the equivalent to x plus y plus z equals 1. So the fund, all of the money that you put into all of these adds up to 1. So when you end up solving for x, y, and z, it'll just be the proportion of your funds that you buy in each one of those. So, so we can add on that constraint. 21. I made a mistake. So if you want, you can solve this system, and it'll tell you exactly what x, y, and z are. I don't know if we'll get there or not. So let's focus on this one for now. So I wanted a 1 in this upper left-hand column, if I could get one. So I saw I already had a 1 here. I just swapped those. Easy. Now I want this to be 0. So I want to use that 1 to get everything else below it 0. So I'm going to multiply this first row by a negative 22 and add. So first row will be the same. You wear out a lot of pencils doing these problems. So this is a negative 22 row 1 plus row 2. So if I multiply, I'm multiplying 1 by a negative 22, then adding. That's going to add to 0. I have a negative 22 here. That'll be a negative 66 plus 34. That's going to be a negative 32. A negative 22 times 3 halves. That's going to be a negative 33. Negative 33 plus 13 is going to be a negative 20. Catch me if I'm doing this incorrectly. Then we have another negative 33 plus 21, that's negative 12. Okay, so I get that. Now, if all I'm after is row echelon form, then I'm good. This is row echelon form. I see I have the pivot, I have my pivot positions are here and here. Those are my two pivot positions. That does answer the question. If I really do have two pieces of information, I do. The number of pieces of information is equivalent to the number of pivot positions, and we're going to call that the rank. When you in the second half of 2.2, you'll read something called the rank. That's the number of pivot positions. So I have two pivot positions here, but that doesn't help me with the solution. Let's keep going, find a solution. So let's make this 1. So I'm going to divide by a negative 1/32. So this is row 3 times a negative 1/32. So that'll get me 0, 1. 20 over 32, 4 will go into both of those. It's negative, so that'll become positive 5/8. And 32, 12 over 32 will simplify. 4 will go into both of those, and I get 3/8, and that's positive. I already did this problem before, so that's why I can do the math so quick. So don't be too impressed. And then, now I want to use this 1 here to get the one above it to be 0. So that one above it right now is a 3. Here, I'll just rewrite this. 1, 3. 3 halves, 3 halves. Oops. 3 halves. So I want all of it for reduced row echelon form. All of my pivot positions need to be 1, and everything else in the columns that the pivot positions are on need to be 0. So I'm going to multiply this second row by a negative 3 and add. So a minus 3 times row 2 plus row 1. So this doesn't change this one. So a minus 3 times 0 plus 1 keeps it 1. See, I don't want to change this. It's nice that I already have this to be 0, because then I can, because it's not going to change that 1 there. So minus 3 times 1 is minus 3 plus 3 is 0. The reason I multiplied that line by a negative 3 was just to get that 0. Now a negative 3 times 5/8, so it's going to be a negative 15/8. If I change 3 halves to 8s, that's 12/8. So I have a negative 15/8 plus 12/8 is a negative 3/8. And then if I multiply here, multiplying by a negative 3. So negative 3 times 3/8 is a negative 9/8. And then if I change 3 halves to 8s, that's 12/8. So I have negative 9/8 plus 12/8, that's a positive 3/8. So, okay, questions? Yes?
When we're using the we have more variables than equations, how do we determine where our pivot points are going to be? Like, why can't one of our pivot points be a 5/8?
So why not make this, why not focus on this one?
And then make the other one 0.
Okay, so we wouldn't be able to make this one 0. We could make this one a 1 and make this one 0 if we wanted to. It would change the value of this. This would no longer be a 1 in this case. Because to make this a 1, we'd multiply by 8/5. So this would now be 8/5. But mainly convention, okay? So there's not, like, we could make this a 1 and make that a 0, but by convention, we made it, if you get it into this, into the rules of reduced row echelon form, then we all know what we're talking about, and it's unique. So it's one of the nice things about reduced row echelon form is that if you have a matrix and you get it into reduced row echelon form, any matrix that's row equivalent will end up in that exact same form. So part of it is we're just picking some rules to live by so that we can all agree and work the same process. Okay, it's a good question. So yeah, once we get a 1 here, we use it to get all the zeros below it, and then we move to the second row, and we want to make this, so we look for the leading coefficient if in this second column, if we can, and we make sure that that's a leading coefficient, and we work from there. Okay. Okay. Other questions? Yes. This is reduced row echelon form. This is as much as we can do. So my pivot positions are 1. The ones. All of the pivot positions above any other pivot positions are to the left of it. So that gets the staircase effect. And every other entry in a pivot column is 0. Yeah, and these aren't pivot columns. So the best I can do is just work with the pivot columns, and these just end up being whatever they are. So, okay. Philip, and then remind me your name? Cambria. Dang it. Okay. You mean like have 1 0 0 1 here, or 1 0 0 1 here? You could. So for those online, the question started is like we're basically picking which variables we're solving for, and that's true. But the convention is we're just always going to pick the. We're going to just start by getting leading zeros from left to right, and then just leave the other ones. Okay. So, yeah, Cambria. Yeah, so if we had a third line like this one, and this does work, if you would get it into 0 0 1, this bottom one. So you can get this system, you can row reduce it so that it is like the left-hand side is this. So you know exactly how much to buy of each one of these. You know exactly what X, Y, and Z is. So you'll know whatever proportion for QQQ, whatever proportion of your money for SPXL, and whatever proportion of your money for URE. So if they are independent, we haven't talked about it, if they're all different pieces of information, basically. But it is possible that they look different, but once you start solving, you end up with all zeros down here, even though you started with 3 equations. So, yeah. Or all zeros on this side, and then non-zero over here, which means there's no solution. But that's coming up in more the second part of 2.2. All right, so we've gone as far as we can. What does this mean? What do we do with this? Now, some of you want to block it out of your memory forever. But this still describes, or we can still use this to describe the solution of the system. We're going to translate it back into X, Y's, and Z's. I'm just going to try to separate that off there. So I can rewrite this as X minus 3/8 Z equals 3/8, and Y plus 5/8 Z equals 3/8. And now I'm going to solve for X and Y in terms of Z. Z is what's called a free variable. Okay, you'll learn more about this in the next pre-class video, but this is a free variable, which means we can pick Z to whatever we want it to be, but then after we pick Z, then we can solve for X and Y. Like X and Y are determined once we pick Z. So we let Z equal whatever Z is. So this is it's It's reflexive here. We just think, okay, z, we'll let z equal z. Then we have an equation for x, an equation for y, an equation for z. So we'll solve up here, we'll solve for x. Here we'll solve for y. We've already solved for z. So x equals 3/8 plus 3/8 z. So I took this over to the other side. And here I have y equals 3/8 minus 5/8 z, and z equals whatever z equals. Okay? Is this starting to look familiar? We're one step away, and I'm running out of board space. Okay, so now I'm going to write this in vector form. This is parametric form, a little disguised maybe for you, but this is parametric form. And we're going to write it in vector form. This is the vector form of a line. Or we can write it as a vector form of a line. So we have x, y, and z equals, I have a point, 3/8, 3/8, 0. Those are the values on this right, those are the constants on this right-hand side. And then I'm going to take the coefficients of z and write it this way, 3/8 minus 5/8 and 1. And then that looks a lot like what we've been doing with lines in R3 or lines in R2. So any solution on this, any point on this line is a solution to my system. It only makes sense in our context right now that all x, y, and z all have to be positive. But I could try picking and say, okay, maybe I'll put $1,000 here and let z equal 1,000, and then I could solve to see how much x and y would have to be to get my return. Okay? Questions? Heather? Yes. Yeah, and generally we will. In this context, it just makes sense not to do that. But we could, okay, let me keep z here. But we could write it as x, y, z, 3/8, 3/8, 0, plus t, 3/8 minus 5/8, 1. So this describes the same line. Right now, z just equals t. But there's some nice things about using t or s instead of z. This is a direction vector, but if I don't like the fractions, I'm just going to multiply everything by 8. And so then I can get a different, there, I can get 3 and minus 5 and 8. I like to work with that better. And t allows me to do this. But right now, t is not equal to z anymore. T is equal to like 1/8 z or something. So if I have z on this side and this side, I can't go changing this. So yeah, does that help? Yeah. In general, we won't keep our z's or y's or whatever they are over here. We'll replace them with s's or t's. So, okay, great question. Other questions? Okay, have a great day. Ugh. Hold on, Michelle. Homework's over here to the right, or your left. Hold on, Michelle. Yeah.